Given question, find the moment of inertia of L section about its centroidal axis by using parallel axis theorem.
In this question, we have to find out moment of inertia of the given shape along centroidal axis. We have to first find out coordinates of the centroid of given shape. We will follow step-by-step procedure. We have to first select x-axis and y-axis so that given shape will be in the first quadrant. I will choose this bottom horizontal line as a x-axis. So I will extend this. And this vertical line as a y-axis. Now the point of intersection of the x-axis and y-axis is known as origin. Now we know that the values on right hand side are positive, values on left hand side are negative, values in upward direction are positive and values in downward direction are negative. So all the measurements of the given shape in first quadrant are having positive sign. Now how to select the coordinates of the centroid G, that is x bar as well as y bar. For that we will prepare one table. Now here we have to divide this shape into simple form of shape. So I will make one construction. I will extend this vertical line. Then here is the rectangle with base 10 and height 125. So I will give here shape number 1. And this is the second shape of rectangle. So with base 85 minus 10, that is 75, and height 10. So here I will give the shape number 2. Now we have to take here shape number. So for the shape number 1. Then second column is for area. So for shape number 1 we have to calculate area. So area, that means 125 multiplied by 10, that is 1250. Now how to find out values of x and y? For that we will first select the center of the rectangle, because we know that the centroid is nothing but the center point. So center point, that is 10 divided by 2 is equal to 5, and 125 divided by 2, that is equal to 62.5. So I will select here center point. So this is the first step. Second step, we have to draw two perpendicular. One is on x-axis and second is on y-axis. So I will draw two perpendicular lines. Now this horizontal distance is known as x and this vertical distance is known as y. Now this x is the middle point of this 10, that is value of x is equal to 5. And what is the value of y? So value of y, that is the middle point of this 125, that is 125 divided by 2. 62.5. Now we have to calculate ax and ay, that is area multiplied by x, area multiplied by y. Now we will move to the second shape. So we will write here the shape number 2. Now for shape number 2 we have to follow the same procedure. Now I will remove this. Now for shape number 2 it is also in the form of rectangle. Again we have to select the center point. Now here this rectangle is having base 75 and height 10. So here is the center point. Now drop two perpendicular lines. One is on x-axis and second is on y-axis. Now this horizontal distance is known as x and this vertical distance is known as y. So how to find out x? So this is the middle point of 75. So 75 divided by 2. So if we calculate this, then here is 37.5. So it is 37.5. So this distance up to this construction line is 37.5 and we have to add this 10. So it is 47.5. So value of x is 47.5. And value of y, so it is the middle point of the 10, that is equal to 5. Now what is the area? So area is base multiplied by height, that is 75 multiplied by 10, that is 750. Here also we have to calculate area multiplied by x and area multiplied by y. In this table, for shape number 1, area is known as A1, value of Ax is known as A1x1, and here it is A1y1. In the same way, for shape number 2, area is A2, here is A2x2 and A2y2. Now we will calculate x bar, that is the coordinates of the centroid G. So x bar is equal to A1x1 plus A2x2 divided by A1 plus A2. So which is equal to 20.9. So we will plot this point on the x-axis. So from origin we have to take a distance 20.9. So here this total distance is 85 and here this distance is 10. So we will select one point. Then in the same way we will calculate y bar, that is A1y1 plus A2y2 divided by A1 plus A2. So answer is 40.9. So from this origin O we have to select the distance 40.9. Now we will draw two perpendicular lines passing through these 2 points. So here is the point of intersection and this is known as G. So this is the centroid G. So this horizontal distance is known as x bar and this vertical distance is known as y bar. Now we will show two axes passing through this point G. So this vertical axis is known as y1 and this horizontal axis is known as x1. Now question is, we have to find out moment of inertia of this shape along x1 and y1. To find out moment of inertia, we have to prepare the other table. So in this first column is shape number. So for shape number 1 we have to show this rectangle and we have to also show centroid G with its axis x1 and y1. Now first step we have to select the centroid for this shape number 1. So that is the center point. So we will show here the center point. Now from this center point we will show the axis passing through this center point. That is known as XC and YC. So this horizontal axis is known as XC and this vertical line is known as YC. Now we know the distance of this centroid G from this x-axis and y-axis, because this is the original x-axis and this is the y-axis as shown in the question. Now this horizontal distance is given, that is known as phi, and this vertical distance is known as 62.5, that we have already calculated. So we will mention here. So from x-axis it is 62.5 and from y-axis it is phi. Now to calculate moment of inertia, we have to select the distance in between x1 and xc. So here xc is this horizontal line and here is x1. So with respect to this x-axis, what is the distance of this x1? So the distance of this x1 is known as y bar. So this y bar is 40.9. So I will select this distance is 40.9. And with respect to this x-axis, what is the distance of this xc? So xc is 62.5. Now we have to take the difference in between these two and we have to mention here. So I will calculate this 62.5 minus 40.9, that is equal to 21.6. So we have to mention here. Now in the same way we have to take the difference in between y1 and yc. Now from this y-axis, yc is having distance phi, and for this y1 it is known as, if we observe this diagram from this y-axis, this y1 is having distance equal to x bar, that is 20.9. So I will mention here 20.9 and here is phi. So we have to take the difference in between these two, that is equal to 15.9. Now we will calculate moment of inertia along this centroid, that is along this xc and along this yc, because we know the formula for the rectangle. So along xc, formula is bd cube by 12, where b is base, that is equal to 10. So if I write here 10 multiplied by d cube, that is height 125 cube, divided by 12. So we have to calculate this. Now moment of inertia along yc, that is this yc, we have to calculate db cube by 12, that is d is equal to this 125 multiplied by 10 cube divided by 12. For shape number 2, we will follow same procedure. So here we have to show this shape number 2, which is having base 75 and height 10. Now we have to again select it's a centroid. So centroid is the center point. Now from this center point we have to show two axes. Horizontal axis is known as xc and vertical axis is known as yc. Now we know the distance of this centroid from the x-axis as well as y-axis. So I will show here. So from x-axis, from y-axis, this distance, horizontal distance, is known as value of x 47.5, and the vertical distance, that is the distance from this x-axis, that is the value of y, is equal to 5. So we have to mention this. Now we have to take the difference in between, that is the difference in distance in between this y1 and yc and this x1 and xc. So how to calculate this? So from this y-axis, if we observe this y1, from this y-axis, this y1 is at a distance x bar, that is 20.9, and the second distance is from this y-axis, this yc distance is 47.5. So we will select the difference in between y1 and yc. So we have to take 47.5 minus 20.9, that is equal to 26.6. So we have to mention this 26.6. Now in the same way we will take the difference in between this x1 and xc. So the distance of this x1 from x-axis, so x1 from x-axis distance is y bar, and y bar is 40.9. So we have to write here 40.9, and the distance of xc from x-axis is 5. So we have to take. Now if we take the difference in between these two, that is equal to 35.9. So we will mention here 35.9. Now we will calculate the moment of inertia along xc and along yc, because we know the formula. So here bd cube by 12. So b is this base 75. 75 multiplied by 10 cube divided by 12. We have to calculate this and we will write here. Now moment of inertia along yc, it is db cube by 12. So d is this height. So we will take 10 multiplied by 75 cube divided by 12. Now we will use parallel axis theorem to calculate moment of inertia along x1 and y1. So we will first calculate moment of inertia along x1, that is known as Ix1. If we observe this shape, then to calculate moment of inertia of this total shape we have to add shape number 1 and this shape number 2. Now we will first observe for shape number 1. So how to apply this parallel axis theorem. So we will take moment of inertia for shape number 1, that is Ixc1, and it is known. So we will take this value plus area of shape number 1 multiplied by difference in between x1 and xc1, that is 21.6 square. So we have to take this difference square. So this is the parallel axis theorem, because we know the moment of inertia along this xc, that is along the centroid, and we don't know the moment of inertia along x1. So how to calculate this? So for that we have to take Ixc1 plus area multiplied by the difference in between distance x1 and xc1, and that is square, plus now we will move to the shape number 2. So for the shape number 2, Ixc2 plus area multiplied by difference x1 xc2 square. So this difference square we have to take. So when we put the values, then we will get the answer 3183661.5 meter raised to 4. Now we will calculate moment of inertia along y1. So we know the moment of inertia along this yc for the shape number 1. So by parallel axis theorem we have to take Iyc1 plus area multiplied by difference in between y1 yc square. So we will take Iyc1 plus a into y1 yc1 square, plus for shape number 2 Iyc2 plus area multiplied by y1 yc2 square. So when we put the data, then we will get the answer 1208661.6 meter raised to 4.